Hello and welcome. This is Matthew, and you're actually hearing from future editing Matthew, not the Matthew when I was recording this video. As you may know, if you watched the end of the previous video, I cut my big long recorded video in half to keep the length a little bit more manageable. So we are picking up today right where we left off in the last video, where I was just wrapping up the summary of this original pick system that ran on the IBM PC. So I'm just going to cut right back into the next thing I was going to say, which was that we're now going to go back to the web browser to look at some more modern systems and the state of implementations that are available today for you. So welcome to the video. If you haven't seen part one yet, feel free to go back and look at that. Otherwise, it's just going to be an abrupt cut here into what is now part two of this video series. Enjoy. So let's go back to the web browser. And again, we were looking here, there are a number of commercial implementations, right? This is the whole big list of just some of the implementations over time of pick-like multi-value systems. Now, one in particular, let's find it here, OpenQM. So OpenQM was developed by a British company called Ladybridge Systems. They were later acquired by a company called Zoomasys, and in the end, Zoomasys was acquired by Rocket Software. So OpenQM is still currently a commercial product from Rocket Software that you can buy. I have no idea how much it costs. But back in 2004 or so, the company, Ladybridge Systems, released the source code for OpenQM for Linux under the GNU GPL. So they didn't release subsequent releases. They kept on developing it. New versions came out. But they did just release, the last version released under open source was version 2.6-6. And again, that would have been 2004. They may have updated, the 2.6.6 release might have been in 2005 or so. But that's open source. So even though they then didn't continue to release it as open source, and again, it got acquired and it got, then acquired by Rocket, who definitely isn't going to make an open source release. We have the source code from that last open source release of OpenQM. Now, I should say the situation in the mumps world is that we have a production quality, mumps implementation that is open source free software. That's GTM, and then the GTM fork YadaDB. We also have a very good open source free software M language reference implementation in RSM, reference standard M. That's what my mumps videos were based on when we weren't being silly and looking back at the PDP-11 version. In the multi-value world, part of the reason that it's taken me a year to get around to doing a video is because I just wasn't really aware of any good working free software open source multi-value databases. I was kind of aware of OpenQM when I did my research, but you try and go get the source code. It only works on 32-bit systems. You have to compile it for 32-bit, or you have to have the 32-bit compatibility libraries installed on your Linux system. And even when I tried it before, it was just kind of annoying because there were some terminal handling bugs, and it just didn't feel like it was really working well. So I should point out that, as mentioned here, in late 2008, a community-oriented group made a fork of that last GPL release of OpenQM called ScarletDME. And the main contributor here to the ScarletDME fork has actually gone through and updated all the code to work on 64-bit systems. So that's convenient because now you can at least compile it and run it on a modern 64-bit installation of your operating system of Linux. But the project is very much in a state of development and Flux. And understandably, as the person who's, again, primarily working on it has other real-life obligations, it tends to go through some periods of dormancy. So the ScarletDME code is available. The dev branch is where the 64-bit port and new development work is happening. And unfortunately, in its current state, the make file is broken. So if you just clone this repository and try and run make, you'll have a problem here. There have been a couple pull requests outstanding for about a year now to, with some fixes for that. And there's a couple other pull requests here that people have put in that kind of combine a couple of different concepts and probably should be broken out into separate requests. But anyway, that's neither here nor there. The fact of the matter is this doesn't currently build. It's just a minor fix to the make file to build it. It's not a big deal. But also it had some of those same little bugs and annoyances that I had found when I was working with the original open source OpenQM code. So again, I was kind of turned off of really learning about and playing with these multi-value things because when I was, when I sort of built and tried to run the source code that was available, it just didn't really feel like it was working well. But recently I decided to give it another shot, and I've done a couple of things. I made a repository here with that original OpenQM code, the original open source OpenQM code, I should say. And I fixed a couple of the bugs that were bugging me, some of the terminal handling stuff. And in fact, we can look at my commit history here. It's pretty short, right? So I started with the open source release. I fixed the build so that it builds on current 32-bit Linux systems. So again, this OpenQM release is 32-bit only still, but it wasn't building on current versions of Ubuntu, Debian, those sorts of things. So quick fixes to get it to build, and then this system actually can run essentially its own telnet server. So users can telnet in to the system, and it can serve up applications, but also just that TCL prompt. And so it was directly going after the password hashes in the shadow password file. But it was only it was checking the algorithm, and it only had one algorithm that it supported, like the old MD5 algorithm. But it was just passing the whole hash off to the system crypt library. So kind of by definition, any hash in the shadow password file will be supported by the crypt library on the system. I don't know why it was doing that. ScarletDME had at least updated the $1 for MD5 to, I think, add the $5 hash for SHA-512, but it still didn't work on my current systems, which have moved on to YesScript, which is $6. So anyway, just verifying against the hash and the shadow password isn't really the right way to do it anyway. You should be actually making an authentication call to the system, because maybe the user has a password in the shadow file, but the password has login time restrictions, or the account's been disabled. So if you actually use the PAM system library to do the authentication, you're getting an accurate answer to, can this user with this password currently log in? There were some sites on archive.org that actually had some old bug fixes to the open source release. So I applied those. And then, like I said, some terminal handling improvements, which I listed all out here. One, make it work with Xterm correctly, and then also recognize Xterm 256 color, which is what most Xterms and like the Apple Mac OS terminal.app set their terminal to. Fixed some problems with the arrow keys not working correctly, fixed some line wrapping problems, and then a couple other little minor things. So long story short, I have now a nice builds and works with some of the bugs I was most annoyed with fixed version of the open source OpenQM release for 32-bit Linux systems. And then I also forked that ScarletDME fork, the 64-bit version, and applied the essentially same set of fixes and changes that I made on OpenQM. So again, the main one is to use PAM for authentication, but then I also fixed up that makefile and changed a little bit how the makefile works. Really, the makefile in this project needs to be kind of redone from scratch to follow more standard makefile practices, but it works for now, so I haven't really dived into that too much yet. But the other thing I did is I created nice, easy to use turnkey Docker images for both of these, for OpenQM. And this Docker image you can run on your 64-bit Linux system because it just has the 32-bit libraries inside the Docker image. But then also for ScarletDME, for my fork here of ScarletDME. So let me show you what those Docker images do. If we just go into the Docker folder of my repository here, we can open up my my entry on Docker Hub here. So of course, all the sources here. If you want to build the, oops, where'd I go? I'm losing my place here. If you want to build the Docker image yourself, you just clone my ScarletDME or OpenQM repository and go into the Docker directory and run the Docker build, and it'll just build it for you. But if you don't care about building it, you just want to run it, the Docker image is going to be the easiest way for you to get up and running with an open source multi-value database that you can play with. So I have a README here that talks all about it. You can set up a directory for persistent data so that you can keep the databases and the programs you make between runs. It is something you can connect to both via SSH as well as Telnet. And then OpenQM actually has a client library that you can use from C or I believe Visual Basic. But the C library actually connects over a socket to the server. So you can write programs in C that run on another computer that are able to put data in, get data out, run some programs through a socket connection to your OpenQM server. So the Docker image supports exposing all of those ports. And yeah, it just works pretty well. So I'll just follow the instructions here. I'm going to make a directory to hold all of my data. That way I can run the image multiple times. If I stop my container and delete it and run it again, I'll still be able to point it to my same data. So let's go to a shell here, and we'll just make dir QM data. And that's where all my data is going to live. And then to run the Docker image, I will give it a name. I'll tell it to run in the background, and then I'll map these ports through. I'll tell it where I want to save my QM data. So it'll be that QM data directory I created. And then Racing Mars /ScarletDME latest is the image name up here on Docker Hub. So I'm just going to copy and paste all of that and go back to my terminal and paste it in. So if I run that, it'll download that image from Docker Hub and it will create my container for me. So if I do a Docker logs of my ScarletDME container, since I gave it that name, you can see it logs some stuff starting up here. What you want to do is look back at the top of the logs here. It will generate a random password for your user called QM user. And this is essentially the user that you'll use to log in and play with your multi-value database. So QM user, and it generates the password. If you look back at the README in the browser, I will note you can launch the container with an environment variable set called QM user _ password. And that way you can just set the password instead of having to look in the log to copy the randomly generated password. So that's in there if you want to do it that way. And the container does stop cleanly. So if you just do a Docker stop, it will cleanly shut down the QM, the OpenQM or the ScarletDME server process. So you can just do a Docker stop, and then you can do a Docker start again if you just want to start that container back up. It handles all of that. Or you can delete the container entirely and then just run a new version of the container pointing to the same data directory. So let's go back over, copy that password. Like I said, it's running a telnet service. So by default, I mapped that to port 4242. And I can log in as QM user with that password. So here we are. I am now in my OpenQM, or sorry, my ScarletDME session here. Again, this works exactly the same way with the OpenQM container running the 32-bit version. So unless you're really into the system and you're aware of the couple of actual new features that ScarletDME added, you probably won't notice the difference between my OpenQM Docker build and my ScarletDME Docker build. In addition to Telnet, you can actually SSH in. So again, if you're connecting from another machine, you can SSH to your host here if you want it encrypted. The SSH listeners on port 4222, that's again based on the port mapping in that Docker start command. And that's going to be QM user at localhost, or again, if you're connecting from another machine, the IP address. This is probably going to give me a key warning. Yeah, because I've run this container before and it generated a different SSH key. The SSH key, now that I created a new QM data directory, that will actually be persisted as well. So if I stop and start the container, but also if I delete the container and make an entirely new version, new container, but as long as I point to the same QM data directory, it will actually persist the keys. So let me just open my known hosts file here and delete that line 78. Oh, I messed that up. What did I do? Vim VI doesn't know about that syntax. Okay, there we go. So now if I SSH into my container, accept the key this time, and it'll be that same password, the randomly generated password, unless you set that environment variable. And so now we're SSH'd into our system. So just like the PIC system operating system, right now that I'm in a OpenQM, really ScarletDME shell, I interact with it using that TCL, terminal control language, terminal command language. I should look up what that actually stands for. I can list the files. I can create file. Let's say we want to make that planets database that we drew the diagram of earlier. So I can create file planets, and that will create the dictionary for planets and then the actual data file for planets. So now if I do list files, I see planets. And my planets file is the data file, and the dictionary is planets.dic. So you can actually have multiple files share the same dictionary. So if you want, a separate file for, sales in 2004 and a separate file for sales in 2005, but you want them all to use the same field names, input masks, all of that. There's ways when you're creating the file to associate it with a shared dictionary. So again, very capable system, really designed and of course evolved over the years to support the common kinds of use cases here. So what does it look like in this more modern multi-value implementation to define my attributes, to edit my planets, to do all of that? Let's go on this planets theme, because I think this was kind of a theme we used in the mumps video as well. So now that I have my planets file, I could just start entering data. There's a line editor, and actually in the original PIC system, there's a line editor that works in a very similar way. There's also a screen editor, which is probably nicer to work with when you're editing existing stuff. But the line editor is actually reasonably efficient to work with if you're just wanting to sort of input bulk data here. So I can say ed, that's the line editor, very much in the spirit of ed on Unix, the standard editor, or edlin on DOS, if you're more familiar with that line editor. So even though I haven't put anything in the dictionary yet, remember we sort of talked about this earlier, unlike the schema in a SQL database, the dictionary in a multi-value database system is purely, advisory. It's purely informational, and it mainly just drives that query and report language, those English access queries, so that if I say, show me the name of a planet, the dictionary tells that system that, okay, yes, there is something called name, and it's going to be the first field, and it should be displayed in this way. That doesn't mean I can't put some totally other random data. I could put the name of the planet in the third field, even though in my dictionary I say the third field is the radius of the planet. Right. So you can really sort of mess up your data, but really you should have a accurately defined dictionary and your own basic code. If you're writing code to interact with your file, I think there's actually a tool to generate a include file that defines the names and the field numbers from your dictionary, so that you don't have to mess up in your code and say, oh, give me field 3. You can actually have a symbol defined in your code for the field named radius, and then if you generate that header file essentially from your dictionary, then you won't lose track of which field number is which. So you really should keep accurate dictionaries, of course. The data in your file really should match the dictionary, but there is no enforced schema. I could have 3 attributes on one row or record and then 100 attributes on the next record. And neither of those records could have anything to do with the fields that I claim I'm using in the dictionary. So before I create the dictionary, I can go in here and I can say, hey, let's edit the planets. And again, it's a key value system. So I have to say, okay, which key in this file do I want to edit? I want to edit key 1. Keys don't have to be numbers. They could be text. Again, they're all just stored as the ASCII string representation of the whatever you type in. But typically, like in a lot of databases, you would probably just use a number for the primary key, unless you really do have a unique, never-changing, easy way to identify the things in your files. So now I'm editing planets 1. It's a new record. I can go into insert mode, and I can just start typing in what I want in each attribute. So we'll say the first one is the planet's name. So we'll just start with Mercury here. And maybe I want to keep the planet's radius. And let's say I want the radius to 2 decimal places, maybe in kilometers, but I want to store the data in that masked value, masked decimal values. So Mercury has a radius of, let me consult my cheat sheet here, 2,440.53 kilometers is the mean radius. So I can enter that as 2,440.53, because ultimately the way that I'm going to treat this data is, again, to have an implied decimal point followed by 2 digits of decimal precision. Now, I might also eventually want to store those moons and probes, but those are the multi-value fields, so I'd have to type in the field or the value mark here, which I'm actually not sure how to do in the line editor. I know how to do it in the screen editor, but you'd essentially enter things like Mariner 10, and then let me see if this works in the line editor. It's Control Q to quote, and then I think V for the value mark. Yeah, no, that didn't work, so just put in a V. But you'd put Mariner 10, and then you'd put the equivalent of the field mark, and then the next one was, say, Messenger. And maybe I'll do the probe launch dates, I think is what I did, right? So this is a date. It'd be something like 3 November 1973, but I would have to know what's the number of days since, what was it, December 31st, 1967, right? So it's going to be some number of days here. And then again, the field mark equivalent character and some number of days for the messenger probe. And then maybe fields 5 and 6, I put the moon and the moon radius. Again, more multi-valued fields, but Mercury doesn't have any moons, so I'm just done there. Now, again, these aren't really the correct value syntax format for multi-value fields here. So I'm actually going to go back to line 3 and delete it. And now the new line 3, I'm going to delete. So if I go back to the top and I print, again, this is pretty typical line editor stuff, right? If you've ever used a line editor, you'll recognize what I'm doing here. But I end up now with a 2 attribute file with the planet and then its radius. So I'll file that, that's save and quit the editor. And now if I do list planets, we see that we have a planet with ID 1, but I'm not showing any fields yet. I can specify, well, I can't say name because I haven't told the system what the name field is, but I can refer to fields by number. So list planets 1 and 2. I hope it doesn't even know what 2 is. Did I? Oh, maybe this doesn't work. There's a way I should be able to say, I thought I could say just the attribute values here. Maybe not. It might be interpreting that as which planets I want to list. But anyway, the point is I was able to create the planet. I don't have a schema. Obviously, without a schema, I apparently don't have a good way of, can I say sort planets 1, 2? Yeah, no, I think it's interpreting that as something else. But if I copy to terminal planets 1, again, you can see that, Mercury's in there with those 2 attributes. But really, of course, as this sort of demonstrates, you would want to define the dictionary for this file. So there's a tool called modify, and we will modify the planets. We'll modify the dictionary for the planets file. And this is asking what field ID do I want to modify. So this is where I can start making my fields. My first field is going to be called name. And then this will actually prompt me for the type of information I need to define the dictionary entries. Now, this definition of dictionary entries in OpenQM is a sort of a different format and a different set of fields than the dictionary entries were in the old PIC system. So this is an area where you can have some vendor specific, right? However, the particular multi-value product works. There tends to be some support for compatibility between some of the modern systems, Universe and Reality and Ultimate. But then OpenQM actually has a bit of a nicer system, but it's not quite as compatible with the dictionary definitions in some other systems. So in any case, again, unlike MUMPS, which became standardized as the M language standard, there is no standard for these multi-value systems. Most of them just kind of start out by copying the way that the PIC system did it, and then branch out from there. So here in the OpenQM world, OpenQM and the ScarletDME fork, we have this nice modify command that knows what fields are in dictionary definitions. So I can just be prompted through all these things. So the type is D. This is going to be a direct data element, meaning it's an actual data element in the file. The location, we're going to store this in attribute 1. Conversion, this is just text, so we don't need a conversion. Name, so this is going to be the display name of the column. So I'll give that name. Format, this is how it's going to display. So we're going to show 8 characters left justified. And then S or M is single or multi-value. This is a single value attribute. And then association is for multi-value. You might have sets of columns that are multi-value, but not related to each other. So you can name those sets of columns, and we'll look at that in a minute. So when I'm done defining name, I can file it. And then we just go on to the next one. So we said we want to keep track of radius. So this again is going to be a direct field. It's going to be the second attribute. This is going to be that number where I have an implied decimal point followed by 2 decimal digits. So I'm going to do a masked right justified 2 implied decimal digits. And when I display it, I want it displayed with a comma for thousands separators. So that's just one of those conversion format strings. The name, we'll say radius in kilometers. The format, so again, this is just going to be how we display the text. So after the conversion happens, I'm going to have a text string that I can display, and I'll just show this as 10 characters right justified. Again, typically you display numbers right justified and plain text left justified. Single value field, no association, file that. So let's pause there for a minute. Now, if I list planets, now I can show the name field and the radius field. And you can see, even though I entered Mercury's radius as 244053, right, that was the correct format for how I define this field having the conversion applied. So again, now that I have a dictionary, I'm able to start using the features of the query language and generate some nice looking reports. The other thing that has happened now that I've defined a dictionary is I don't have to use that line editor or even the screen editor. Just like we said, modify dictionary for planets, I can now actually just use that same modify program to modify planets. And I can say planet 1. And now I have an editor where I can edit the planet Mercury using the field definitions there. So if I want to change the radius, I could say 2, and it'll prompt me for a new radius. I'll just leave it the same. I can also add a new planet by saying modify planets 2, right? So this will be Venus. It's prompting me for the name, Venus. It's prompting me for a radius. So let me look here. Venus is, now again, it's going to be smart, right? I can enter 6, 051.8. Now we know, underlying in the data, this needs to be stored as 605180 because I need those 2 positions for the implied decimal point at position 2 to work. But if I just leave it as 0.8, the system knows, this modify tool knows how it should be stored because of the definition, and it will store it correctly in the underlying system as 6051.80. Right? If I change that, if I don't enter the commas, if I don't enter a decimal, it'll still do the right thing. Similarly, if I change number 2 to 6051, and right, if I say 88943, it should round it up to .89 and then just store, again, the final 605189 in the underlying data, and we can show that it is in fact storing, it's displaying it that way. If we actually look at the underlying data for planet 2, it has converted it and stored it as 605189. So let's modify planets 2 again, and let me just change that back to 6051.8. Okay, so list planets, name, radius. Now, what about this multi-value stuff? So we know that the moons and the probes need to be multi-value. We also have, I kept saying the type is D for direct. What else can we do there? So let's say modify the dictionary for planets. If you do question, you actually get a nice little select list. And the arrows now work in Xterm, but you get a select list. But in fact, I don't want to edit one of the existing fields. I need to edit a new one. Let's say we want the planet's diameter available in reports, but we don't want to have to enter the diameter. We already know the radius. So instead of direct, we can say that this is and a type of I. I don't know if this stands for implied or inferred or indirect, but I just remember it as inferred. So it's a type I. Now location. Well, location, this isn't an attribute in the file. I want to compute this. So instead of an attribute number in an I type field definition, you can actually give it an expression of how to find the data. So in this case, it's simply going to be radius times 2. Now, because of the data format of radius, we would want to use the same data format here for the diameter. So that's going to be mr2 comma. The comma would be optional. Maybe we don't want to display the diameter with the thousands separator, but it would be important to keep the decimal point in the right place. So the mr2 is the important bit there. We can call this diameter. Again, display format, what did I do? I think I did 10 characters for the radius. If we multiply by 2, we might have 1 extra character after the multiplication. So I'll do right justified 11 characters. And then this is a single value field and no association for single value fields. So let's file that. Let's quit out of the modify processor there. And now if we do list planets, name, radius, diameter, you can see, sure enough, it computes the diameter. And you don't need to display radius, right? It's looking at the actual data, not just the on-screen display. So diameter will still display here if that's the column you select. So those I type fields are convenient if you want to make computed data or data that has to do maybe some other lookups in other files even. So you can kind of do a relational thing if you do want to tie one file to another and then just have a field that's available for working with here. So let's continue. Let's keep on modifying our dictionary for planets. And let's go on to, let's do the probes. So we're going to store the probe name. So this is, again, just the rest of these are going to be direct data fields. The probe is going to be, I think we're up to position 3. No conversion. This is just going to be text. The name is going to be probe. Let's give it maybe 12 left justified. Now probes, there can be multiple probes. So instead of single, S for single, I'm going to enter M for multiple. And all of my attributes related to each probe, I'm going to call the probes association. And by giving it the association, we'll see that that modify program, when I'm editing planets, is going to know to group together the probe data separately from grouping together the moon data. So I'll just go through the rest of these somewhat quickly. So launch date, this is going to be another data field. Whoops. So technically, this is a case-sensitive system. When you're running commands and when you're putting in file names and column names and things like that, if it doesn't find the exact case that you entered it in, it will try again in all uppercase. So you typically want to make sure that you're naming your commands that you create and your files all uppercase, but then you can refer to them just by typing them in lowercase as you go, and it'll find them in uppercase if they're there. But when I'm actually editing this data in here, you know, type needed to be a capital D. Lowercase d isn't a type that it knows about, so I'm just getting random field attributes here. So I'm actually going to cancel out of this and try again. Can I just change that back to a capital D? Yeah, now what I don't know is if it ended up with too many blank fields, so I'm just actually going to quit that without saving, and yeah, it didn't save that. So let me do that again. So that's going to be launch date, capital D for a data item. And where were we? We were at location 4. Now, this is a date, one of those funny number of days since December 31st, 1967. So the conversion for a date, if I just want, you know, a full date, month, day, month, year, is just the letter D. I'll call this launch date. The format here will give it about 11 characters, right justified. And we will say this is a multi-value, and this is another field in our probes association of multi-value fields. So that's good for launch date. And we'll do the same thing for moons. So I'll just do moon. It's going to be field 5. It's plain text. We'll call it moon. Moons, I think 10 left justified will be enough. It is multi-valued, and this is going to be part of the moons association. And last but not least, let's track the moon radius, just so that we have another data element to show the multi-valued association. So direct, last field is 6. And the radius, again, we want a number. We probably don't need to track, tenths of kilometers in moon radii. And we do want to show a comma for 1,000 separators. So we'll use that as our number mask. I'll call this moon radius in kilometers and give it 6 characters is probably enough. And this is going to be multi-value, part of the moons association. So file that. We can look at the list here just to confirm. Yep, we have all these fields. And now if we go back in and we say modify planets 1 for Mercury, you'll note here that we have the 1, name, 2, radius. Attributes 3 and 4 now have this little arrow, and they consist of the field moon and moon radius and probe and launch date. So this is how, this is why we put in those associations, because now the tools in the system know that these 2 fields are related to each other and these 2 fields are related to each other. Now, Mercury doesn't have any moons, but we have sent some space probes to Mercury. So I can go into menu 4 here for the probe and launch date. And then we just have numbered items. So I can say I want the first item. This was Mariner 10. And the launch date here, I can enter it as 3 November 1973. And that'll get computed as the correct number of days to store in the underlying data. So let's just quickly add messenger, and that launched on 3 August 2004. So that's it for my Mercury probes. And in fact, that's it for Mercury. We can modify planet Venus. Sorry, modify planet 2. Sorry, again, planets, plural. I need to remember what I called the file. Venus doesn't have any moons. We have sent some probes to Venus. I'm not going to enter them here, actually, because it'll just be like Mercury. You'll just see a list of probes with no moons. So to save time, sorry, poor Venus. We will modify a new planet. Let's enter Earth. So that's planet 3. Planets, it's the file name. So that's going to be Earth. What do I have for radius of Earth here? 6378.1366. Again, it'll do the rounding for me. And now, as soon as I enter the radius, because I'm entering a new planet, it has dropped me into the moon editor. So attribute 3 of planets. So now it's asking for the first moon. In this case, we'll say the name is Luna. And the moon radius is 1738.1. Again, we're not keeping decimal places based on our mask, so it just trimmed off the decimal place and rounded. It's asking for the next moon. That's it. I'll just hit enter. And if I hit, I believe, enter again. Yep, so that exits the moon editor, and now we're on the probe association. We're not going to count all of the launches to orbit Earth as space probes to explore Earth, so I'm just going to hit enter because there are no probes. I'll hit enter again to leave the probe editor. And now I've finished entering in Earth, so I'll file the Earth record. Let's just do 2 more. I know this is kind of taking time, but we'll then be able to do some actual, a bit more interesting reporting maybe. So let's modify planets. Mars is going to be planet number 4. So again, Mars, what do I have here? 3396.19. Of course, we have Phobos, which is a mere 11.08 kilometers. And then we have Deimos, which is even smaller at 6.27 kilometers. We have sent a lot of missions to Mars. Let's skip those for the sake of time. So we'll just exit out of that, file that, and then the last planet we'll do a couple more missions and say the Galilean moons. So let's modify planets. Jupiter would be number 5 if I'm counting correctly. So Jupiter's a big one, 71,492. And we'll do Io at 1821.6. That should be rounded up to 1822, and sure enough, it is. And we can do Europa, which is 1560.8. Ganymede is 2634.1, and then Callisto, which is 2410.3. I forgot to capitalize the E in Europa, so I can edit number 2 and just change that to Europa, keeping the same radius. Great, so moving on to the probes, I'll just do the first 2 Pioneer missions. So Pioneer 10 was 3 March 1972, and then Pioneer 11 launched on, I think I can do like April 6th, 1973, and it'll figure out the date format. Oh, nope, apparently for text entry, it is picky about the format. So 6 April 1973. There we go. That's it. We'll file away Jupiter. And now, if we list planets, you'll note we're still not getting any fields by default. And of course, we're getting in random order. So if I sort planets, I'll get them in the right order, but I still have to say sort planets. And then I have to say all of this field IDs. So name, radius, I can include diameter if I want, probe, launch date, moon radius. And that doesn't fit in a column form, so I'm getting that list view of each planet. So I can hit Q here. One thing you'll note is that by default, it thinks my terminal, actually there's a term command to show this, it thinks my terminal is still 80 columns wide and 24. It doesn't actually probe the terminal width when you log into the system. And I wrote a little program in mumps to use the VT100 codes to interrogate the terminal and figure out the size and automatically set the terminal size. I want to do that in QM basic here to be able to auto detect the terminal size, but I just haven't done that yet. So I'm just going to tell it that my terminal is 112 columns wide by 28 lines high. That I just happen to know that's the size of this X term here. So now if I run term, page width is 112, page depth is 28. Let's run that same sort planets query again. And now it just fits. And so it's able to display it in the nice column report view. So you can see here that we have our planets. So planet 1, and again, we got the multi-value field here for the probes. And Earth only has 1 moon. Mars only has the 2, so we're getting those multi-value sets. Jupiter, I entered both probes and moons just so we could see that we have the 2 distinct multi-value sets here. All of the formatting is correct. That all looks good. One thing you might notice is odd here, though, is for Mercury, we're just showing a moon radius of 0 for a non-existent moon. Same thing with Venus here. So we don't really like that, but that is coming from the fact that we said, hey, the way you display a value in this field is with this decimal mask. There's an option in the decimal mask to actually say, you know what, if it's a 0 value, just just use a null string. Don't actually produce a string that's then going to be formatted by the output format. So let's, one last time, modify the dictionary for planets. And that was our moon radius field. Yes. So under the conversion here, let's edit the conversion and just add that Z option to suppress 0 values on the end of that. Now, if I run the same query, there we go. We no longer get the blank. We no longer get the 0 there. We're getting just the blank, which is what we want. Now, as you probably noticed, because I pointed out a couple times, if I just do sort planets, right, I don't get anything. I have to do, let's just make this a little bit shorter. I have to actually list out all the field names. I can put a special entry in the dictionary just with the ID of @ instead of one of my other actual field names. And @ is going to be the default set of stuff that gets put into your query. So I can do, this I'm going to use the line editor for. So I'm going to edit the dictionary for planets, and I want to edit the record with the key the @ symbol. And we're going to go in insert mode in the line editor. And this is going to be a paragraph type entry, right? This is normally where you'd say, D for a direct field or I for one of those inferred fields. There is a record type called paragraph that lets me essentially just put TCL commands or just miscellaneous stuff. So here I can put the fields that I want displayed by default. So that's going to be name, radius, probe, launch date, and then what else do I have? I have moon and moon radius. Okay, and then I just hit enter and file that. So now if I sort planets, it should use this as just sort of being appended by default to my sort and list commands. Except it didn't work. Oh, that's because I was wrong about what this should be. Yeah, so this shouldn't be PA. This should be PH, phrase, not paragraph. I think phrase. So I'll use the replace line editor command here. Now if I print this out, okay, phrase. We'll file that. Now let's sort planets one more time. Yes, perfect. There we go. So now I'll get a default set of fields. If I say sort planets, name and radius, I can still get a more limited or a different set of fields. But now I have a reasonable default so that I just get a nice report if people just come in and say, hey, sort planets. You can do other things in your reports here. So sort planets, you'll note that it always shows the planet ID or the key, right? So this is the key for this record in the file. There are some options I can put at the end of my my things here, and we talked about this when we totaled up the company invoice totals in the old PIC system. So I can do ID. Is it suppress ID or ID suppress? No, it's ID suppress with 1P. I already forgot from earlier. I thought it was ID suppress. Oh, ID. It helps if I type it correctly. Okay, ID suppress. Yeah, there we go. So now it's no longer displaying that number. I'm just showing the planet names, but then it's still sorted by that key. So I'm getting the planets in the right order, but I don't need to have a whole column just showing 1, 2, 3, 4, 5. That is something that can be added to that default. So if I say edit dictionary planets @ I can add that. So if I go to 2, and if I just replace that with ID sup, Now, if I sort planets without ID sup, because that's part of my defaults, since I don't specify anything else, that's no longer listed. And then the last thing I want to show you is you can add headers and footers. So I can say something like sort planets, and we can say heading, and I can give it a string here, solar system planets. That'll print that at the top of my report. Now, if I want that formatted a little more nicely, in single quotes after a line in this heading string, there are a couple of letters you can put in to do different things. So C will center it. So now you can see my title is centered. L will put a new line after it. So CL will center it and then insert a new line. So I get a little bit of spacing between the title and then my columns. I can do another line of text after that. So I can say, maybe as of, because, these things change so often. A D will insert a date. I can center that last line and then put another line after that. So there we go. So I can say solar system planets as of, and it'll do today's date. And that's all nicely centered. If you want, you can add this heading to your default entry there in the dictionary. So if we add dictionary for planets at again, if I go to line 2, there's probably a way to append this, but you can do a continuation character. So I'm going to replace line 2 with that followed by a continuation character. And then I'm going to insert line 3 where I will, do I have my heading here? I can copy paste. I think I copied it. Yeah, I'll add the heading here. Okay, so now if I look at this whole thing, we have the fields, the ID suppression, continuation character to go onto another line, and then the heading. So let's file that. And now if I just say sort planets, I get all of it. I get my heading, I get my planets listed with the default fields. And last but not least, if you sort planets, you can also do footers. So footers, you say footing, and maybe I want to do a page number. So that's going to be page, and then in single quotes, P. And again, we can center the footer line. And there we go. So of course, if I had multiple pages, you'd see that, but we don't have enough data here to have multiple pages. So that's it. This was, as always, a long video. I think I'm going to cut it off here. But you can sort of see how this works, right? Whereas when we were looking at mumps, we were really focused on the programming language because there's nothing else in mumps but the programming language. Like I said, it's a programming language that happens to have a database built in, which lets you store global variables in your programs. But as you can see here from the PIC system, it's really, we haven't looked at programming at all, right? We have not looked at a single line of basic code. I haven't even shown you where the code lives or how you'd edit it. Although, as you can imagine, you could use that line editor we looked at to edit your basic code. But we haven't looked at any code. We've just looked at the database system and the reporting system and how we can make dictionaries to teach the query, the reporting system, how our data is laid out, how we want it stored in terms of conversions and display. We've looked at the concept of multi-value databases where we can have these associated sets of multi-value fields along with our single value fields instead of having to build out separate files and do the relationships like we would do with a normalized SQL database. So the PIC system and these multi-value databases, they really are, first and foremost, pretty, feature-packed database management systems and interactive database management systems, and that you just get a prompt at your database here where you can do all of these queries and reporting. So pretty interesting system. You can expect a follow-up video just to touch on programming a little bit. We might just write some basic code that can, maybe display and input these planets in a different way. Maybe, I don't know. I haven't decided what we're going to do yet. But like I said, this has probably been a long enough video for you at this point, and hopefully gave you a taste of what these multi-value database systems are all about. In the links in the video, I will be sure to, or I should say in the description of the video, I'll be sure to leave links to everything we looked at here. The repositories where you can get the source code for these multi-value systems, the Docker page here. As I said, if you just want to start playing with these things and you use Docker, this will be by far the quickest and easiest way for you to get up with this turnkey Docker image. You'll get a container that you can connect into and just start playing with your multi-value system right away. So hopefully this was interesting. And yeah, let's just end back with our classic, the original PIC system. Of course, this was, by this point, a couple decades after the real original PIC system was actually created, or the original reality system. But I'll also leave a link to someone actually relatively recently, the actual install floppies for this surfaced, and someone was able to figure out how to work around. Of course, they were floppy disks back in the mid to late 80s, using the various funny floppy disk copy protection systems at the time. But one of the people who posted the floppy images for this was then able to figure out how to actually patch the main program disk a little bit to get around the floppy disk copy protection implementation, which is nice because now that allows us to run it under emulation here, and we can actually look back in history a bit and play with the actual real PIC system that was an operating system you can install. Anyway, I'll leave a link for that as well. So thank you so much for watching. Let me know down in the comments if you have any questions or experience with the PIC system. I will add, and sorry, I keep saying I'm going to end this video, the Dynix library system. This would have been a PIC system that I interacted with quite a bit. This was one of the early library automation systems, and both my school district libraries and my public libraries in the county that I lived in here used this Dynix software, and Dynix was all implemented in PIC. Let's see if they mention that here. I'm sure they do. Yeah, it was based on developed software, blah, blah, blah. Written for the PIC operating system for the initial search engine tools, and then it just grew out from there. So you can see here, right, there were just these terminals sitting around in libraries and in the school library where you just interacted with this whole front-end system that was written in PIC. But the actual staff and librarians, they would actually have some access to that TCL prompt to be able to run direct English access queries against the bib file. That would be the bibliographic file, and probably some of the authority files for things like authors. So it would be really cool if someone kind of, I don't know, leaked the source code, or leaked some install media, surfaced some install media for this old system. The Dynix company still exists. It got merged in, several mergers over the years. I think the company is now called Circe Dynix. The old PIC code is no longer supported. The original Dynix library software implementation is, now kind of officially dead. Their current library software is all, of course, web-based for the end-user terminals and everything like that. But this Dynix library system was, huge. It was used by, probably thousands of library systems by the time other competitors came along and started stealing business away with more modern interfaces, and again, web-based interfaces. So anyway, just a side note, you may have interacted with a PIC system without knowing it. But it'd be it'd be really cool to be able to get something like this software up and running in one of the Pick Multivalue products. Okay, that's it. Like I said, let me know down in the comments if you've had experience with Pick, if you have any questions about what I've covered so far. I'm by no means an expert. I just mostly taught myself everything I know about these multi-value systems in the last couple weeks. And then I, like I said, got into sort of fixing bugs and working on the code for the OpenQM ScarletDME system. So if you do have questions, I probably won't know the answers, but I might be able to find the answers somewhat quickly. And if you like this sort of stuff, go ahead and hit the thumbs up, and I will see you in the next video. Thanks again for watching. Bye-bye.